Let's have a look at this example here. This figure shows a 20 by 20 matrix of integers. So each number, let's call this matrix X, which is a 20 by 20 matrix, and each element Xij is an integer between 0 to 255, and this is represented in the form of this picture here with yellow and green and red pointing towards higher values, whereas blue pointing towards the lower values. Now if we have to store this matrix or transmit this matrix, naively we would have to deal with 400 times 8 bits, so that is 3200 bits of data. But we can be a bit smart and study this matrix and look for patterns. Now it turns out that this matrix can be represented as this one here. So I have created this example in a way that there is no loss of information, and we can exactly build this matrix by having a column vector multiplied with a row vector here, which is to say that this is a rank 1 matrix. And if we now transmit these two column vectors separately, it would then mean that 20 numbers here, so that would be 40 numbers times 8 bits, which is 320 bits. So in this extreme example, we see that we could basically just transmit 320 bits, which is 10% of the naive approach of storing or transmitting this matrix, and still have no loss of information. And this was because this is an extreme example. But now let's look at the problem given to us. So the image file that is given to us can be represented again in this picture form here. So we have a 10 by 10 matrix ranging from, so where each element of the matrix has integer values ranging from 0 to 255. So let me just write that again here. So let's call this X, which is a ten by 10 matrix, and Xij is an integer taking values from 0 to 255, and I've represented this in this form here. Now if we do a singular value decomposition of this matrix, we obtain something like this. So this is our given matrix X, this is U, this is the sigma block, and that's the V transpose block. I've plotted here the singular values, and we can see that so we have two significant values which are seen in this block and this block here. So this block, and the other values are close to 0. So if we now truncate the U and the V as here and rebuild a matrix just based on U tilde and V tilde transposed and this block, we get something like this, where we've truncated the lower blocks and just kept the, what we get is this. And now we can see that these two figures look reasonably close or similar, at least to the human eye. We can of course also compute the error between these two figures, and that is done in the MATLAB code, and I encourage you to have a look at that. But this is the basic idea. So now we can further factor this. So we can further factor this into two blocks and carry out these two products. So if we did that, we would then need to transmit these 20 numbers and these 20 numbers, each of which are 8 bits long, instead of the naive approach of transmitting all 400 numbers 8 bits each. So now let's look at a more realistic example. So you can download an image. You can play with any image of your own choice. I just downloaded this default MATLAB image. So this is a 512 by 768 pixel image. Each image is represented by 8 bits. Each pixel is represented by 8 bits. So that leads to about 3 megabytes of data. Now if we do a singular value decomposition of this matrix and plot the singular values, we obtain something like this. So here you can see the singular values, and a reasonable point that you can also play around with in the code to truncate is say around 100. So now if we reconstruct the image by considering only 10 singular values, we get this image, which is clearly not close to the image that we want, and this being the error, which is the difference between the actual image and the compressed image. If we reconstruct the image by considering 20 singular values, we get, which already starts looking somewhat like the actual image that we have. If we consider 100 singular values, which is still 1 MB, that would be this image, which now looks reasonably close to the image that we wanted to transmit. So what we've done is that we've converted a 3 megabyte image and reconstructed it by storing or transmitting 1 megabyte of data. Yeah, so that's it for this problem. Thanks a lot.